Hi, my name is Alusine Barrie. Welcome to this sample problem on graphs. Previously, we talked about functions, where we introduced the concept of functions, what a function is, different types of functions you might come across in a W.A.S.C.E, where those functions come from. Okay, functions can talk about anything, whether the way particular products behave in a market or what someone gets from doing something. Like a farmer can get a particular number of fish from the number of hours he puts in his fishing. So you can define the function y, the number of fish he catches, depending on the number of hours he spends. Okay, so this can be described in different types of functions. It can be quadratic function like the ones we're dealing with here. It can be a linear function where you might have 2x plus 1 or whatever. It might be like a logarithmic function or a trigonometric function. Okay, in this lesson we are going to focus on solving problems on the W.A.S.C.E that require you to graph quadratic equations. Okay, quadratic functions rather. Sorry, those are two different things. Right. Like I say, graphs gives you an opportunity to have easy credits in the W.A.S.C.E. This is simply because these problems are often very straightforward. They don't require like rigorous maths that other topics will need. Okay, so the particular objectives for this lesson will be for you to be able to complete tables of values for different relations. You'll be able to use scales of different units to draw your graphs and work with ranges. As you can see here, we have a range. You will also be able to use your graph to answer different types of questions, especially roots. You also know how to estimate values. You know how to find or calculate the gradient at a particular point on a graph. Okay, without wasting time, let's go on and do it. And the resources you need for this video would be a graph paper, pencils, a ruler, and an eraser. Okay, now let's see what we have. Now, so what we can do, the first part of the question says copy and complete the table of values for the relation y equals to 3x squared minus 5x minus 7. Now, first of all, just to give you a general hint, whenever you see the preceding, like the coefficient of x squared, this term is an x squared, the coefficient, if it is positive, you have to know that the graph will often take this sort of U shape, right? If it is negative, say you have y equals to minus 3x squared or minus 9x squared, whatever. If it is negative, then you imagine that the graph will turn out like an N. So often what you can imagine, N for negative. Okay, so whenever it starts with a negative, you know that the graph should turn out this way like an N. I think that's a cool way of thinking about it. Okay, let me take that off. Now what we are going to do, we are asked to copy and complete the table of values for this relation. Right? Let's see. Let's scroll down a little bit. There are often two ways students will do this. They may often like draw a table of very long, like a table like this, where they will have, say, this is the x values, and then they will have different points on the table where they have, say, 3x squared, they put minus 5x minus 7, and all of these, once you do them, they should be able to get the values of y. Okay, so now what you can simply do is to extend the table to cover all the range of values. Okay, what is this range of values? The range of values is simply the range you've been given in the question. So you can see here the graph we are supposed to plot for this question ranges from minus 3 to 4. So the values of x are between minus 3 and 4. One key thing you need to notice, whenever you see this symbol like less than or equal to or greater than or equal to, this often means, when you see this underline, how do we call it, hyphen, okay, subscript, How do I don't know. But when you see this, it means you should include the value you see here. If it was written, say, minus 3, and they just put less than x is greater than 3, minus 3, then you should not include this minus 3. So your values will start from, say, minus 2, minus 1, and head on. Right? But when you see x is greater than or equal to, where the thing turns is where you say greater than. Okay, so x is greater than or equal to 3, so that's why you have to include 3 in the table. But when they say just x is greater than 3, well, you know, 3 is not supposed to be included, minus 3 is not supposed to be included, because x is greater than it. Okay, right, so that's something to know about the ranges. Okay, and x is less than or equal to, it is either less than or equal to, so that's why you include the 4. Right, so keep those that in mind when you are working with ranges. Now, so let's change the ink. So we have x values, so we put x when x is minus 3, when x is minus 2, when x is minus 1, when x is 0, when x is 1, when x is 2, when x is 3, and then we can add for when x is 4. You will learn to do this much neater. Okay, right, okay, so now what you can do, we say simply 3x squared. So each of the values of x, you are going to square them. Okay, so 3 times x squared. So what is x squared? First of all, what is 3 squared? 3 squared minus 3 squared is minus 3 times minus 3. Okay, so but minus times minus will give you plus, and then 3 times 3 will give you 9. So this is why you have this as 9 here. 9. 3 squared is 9. 9 times 3 is 27. So this value x, once you square x, you multiply it by 3. And now you come to you. So let's do that for all of these values. In fact, let's do just for one, and then you see if it matches what we have here. So minus 5x. So the value of x, you multiply it by minus 5. So now we have minus 5 times the value of x. What is the value of x in this column? It's minus 3. So in fact, we should multiply that. So minus times minus is plus again, and then 5 times 3 is 15. So therefore, you put 15 here. And then minus 7. There is no x value to multiply with this. So we just put the minus 7. Right? So this we have now here. So we add. Okay, we add them all together. So we have, let's see. Okay, we still have some more time. We say 27 plus 15 minus 7. Okay, so 27 plus 15. So 20 plus 10. 20 plus 15 is 35. 35 plus 7 is 42. So 42 minus 7. 42 minus 7. Okay, so 2 minus 7 we cannot. So what we do, we borrow 1 from here. So 12 minus 7 is 5, and then it remains 3 here. So we just put the 3. So this is why the first column is 35, just as they have in the question. Okay, so this is often a good way. Look at, they will give you examples in the table, so you will have to look at them now. You try one of them. If the answer is correct, then you have a good idea that you will be able to get the rest of them. Okay, so we say minus 2, we come for minus 2. Similarly, we do what we did before. We say x squared, 2 squared minus 2 squared is 4. Okay, because minus 2 times minus 2, minus times minus is plus, 2 times 2 is 4. Right? Well, if you know your table of squares, this will just come from your head like that. Okay, so minus 2 squared is 4. 4 times 3 is 12. Okay, minus 5 times x in this column is minus 2. Minus times minus is plus. 5 times 2 is 10. And then we put our minus 7. So we do the same thing as we did here. 12 plus 10 is 22. 22 minus 7. We say 22 minus 7. In fact, let's just say 20 minus 5 is 15, right? Because that's 2. So we have 15 in this case. Okay, now we continue. So we have 35, 15. Well, as you can see, because you are often given some bits of, you already have 1, 2, 3, 4 problem solved for you. There is a quicker method you can use to do all of this. Okay, so now sometimes if you are not given the table, you have to do all of that on your own. It's very rare actually. So for -1, similarly, -1, we have to say 3x squared. The value of x for this column is -1. -1 squared is just 1, because -1 times -1 gives you 1. Minus times minus, so let's just do that. -1 times -1, because that's what 1 squared, -1 squared is. Minus times minus gives you a plus, and then 1 times 1 is 1. So you have plus 1. So 1 times 3, because it is the value of x squared times 3. So 3 times the 1 we have is just 3. Right? So -5 times the value of x, which is -1 here, is -5 times -1. Like again, we say minus times minus will be giving us plus. So 5 times 1 will be 5. Right? And then because the -7 is constant, does not have any x value with it, we just put -7. Okay, so we say now we have 3, we add the 5, it goes 8. 8 minus 7 gives us 1. So the third value on this table is 1. And then we come to divide 0. So for 0 we said x squared, so 0 squared is just 0. 0 times 0 is 0. And 3 times 0, any number you multiply by 0 is going to give you 0. Okay, so we have 0 here. Let me illustrate this for those of you who have problems. So we have 3 times x squared, and the value of x here is 0. 0 times 0 is 0. So 3 times 0 is going to give us 0. So that's why we have 0 here. Okay, and then -5 times 0. So like I said, anything you multiply by 0 will give you is 0. Right? So this is also 0. So 0 plus 0, because -7 is constant, we keep putting -7. So as you will see, you will be having -7 throughout. So these numbers or values that are constant, that do not have any x value related to them, we just have to write them up in the table like this. Okay, so 0 plus 0 is 0. 0 minus 7 is just -7. Okay, -7. And this is because, say we have 0 minus 7. Right? So when the bigger, you have to add the numbers. So you subtract the numbers, but the answer should take the sign of the bigger number. Right? This is like the basic rules of addition. So when you have numbers of different signs, you subtract the smaller one from the bigger one, but the answer should take the sign of the big number. So we say 7 minus 0 will be giving us 7 basically, but the answer should take the sign of the big number, which is 7. So we say -7. And then we come to the next one, 1. For 1, we'll say we have 3 times 3x squared. Okay, so the value of x here in this column is 1. So 1 squared is 1, because 1 times 1 is just 1. So 1 times 3 is just 3. So minus 5x. So now we have minus 5 times the value of x, which is just 1. Okay, so minus times plus. Remember, if there is no sign in front of a number, it is plus. This is a rule also. So minus times plus is minus. 5 times 1 is 5. So we have minus 5. So now we have, in this case, 3 minus 5 minus 7. But the rules of addition tells us that we should have whatever we do. Say we have here now 3 minus 5 minus 7. We should always add before we subtract from the word BODMAS. Okay, BODMAS, brackets, others like multiplication, we divide first, we add before we subtract. So now let us try adding. So in this case will be minus 5 minus 7 will be giving us minus 12. Right? So we'll have 3 minus 12. For 3 minus 12, is going to give us minus 9. Okay, so this value is 9, just as you see here. Right? I'm doing this for just to give you an example, because ideally you should just consider this. So 4 ones are the ones you should work on basically. Okay, but this is a way of knowing how to set the table from scratch. Now, when you are just given the relation, so now we know that this is minus 9. For 2, we do the same thing. We say 3x squared. 2 squared is 4, because 2 times 2 is 4, and we multiply that value by 3 as we have been told. Okay, so 3 times that 4 is going to give us 12, minus 5x, and the value of x is 2, so minus 5 times 2. We know when we multiply a negative number with a positive number, the result is negative. So minus 5 times 2 is going to give us minus 10. Okay, so now we have 12 minus 10 minus 2. Right? So we always add before we subtract. Sorry about that. So we always add before we subtract. So minus 10 minus 7 is minus 17. So 12 minus 17 is going to give us minus 12 minus 17 is going to give us minus 5. Okay, so this is, so for 2 we have minus 5 here. Okay, and then for 3 we have 3x squared. We are going to square the value of x, which is 3 in this column. So 3 times 3 is 9. 9 times 3 is 27. Okay, and then we have minus 5 times the value of x, which is 3 in this column. So minus 5 times 3 is minus 15. Okay, so now we have minus 15 minus 7. Okay, so minus 15 minus 7 is minus 22. Minus 22. So 27 minus 22 is going to give us 5. So this is why you see the value in the original table. The question says 5. Okay, and then we have for the last one, which is 4. We have let's just see how much time we have. Okay, good. So we have for 4. We do similarly. We multiply the value of, we square the value of x, and then we multiply it by 3. Okay, and then 4 squared is 16. So 16 times 3 should give us 48. Okay, this is why you should know your multiplication tables. Like, practice those things, guys. So 48, and then we say minus 5 times the value of x, which is 4. We know when you multiply a negative number by a positive number, the result will be negative. Okay, because minus times plus is minus, and then 5 times 4 is 20. Right? So now we have 48 minus 20, and then minus 7. Remember, the minus 7 is constant. So we say 48 minus 20. This will first of all leave us with 28. 28 minus 7 is going to give us 21. Right? So now we have completed the table. This is the first part of this question that asks us to copy and complete the table. Okay, I told you earlier, let me see how much time we have, that you can do this much faster, right? Or differently. Let me don't say much faster. Okay, let's just have our relation here as y equals to what was the question? 3x squared minus 5x minus 7, and have our 2 row for our values. Okay, so we have x values and we need the y values. We have already been given sum for minus 3. We already have 35. Let's just put for the other ones, and then we can start the other method. So minus 2, we have minus 1, we have for 0, we have 1, we have 2, we have 3, we have 4. Okay, the other ones we are given, I think we were given 15. No, let's just scroll to the original question and see the ones we were given. So we were given 35, we are given 35 minus 7 minus 9 and 5. Okay, so let's go down and try and see. So 35 minus 7 minus 9 and 5 are given to us. Okay, so we have 35 minus 9 minus, completely missed that. Let me just this out. So we are given 35 minus 7 minus 9. Okay, 35 minus, so for 0 minus 7 minus 9, and then we are given 4, 3, 5. Okay, and we are supposed to find the rest of them. So now for minus 2, we can simply see when x is minus 2, we expect y to be the value, the image of this value of minus 2. So this will be 3. Anywhere we see x now, we put the value that is supposed to be minus 2 squared minus 5 times what the same value of x, minus 2 minus 7. Okay, so we have minus 2 squared is 4. Okay, so 3 times 4. Okay, so 3 times 4, and then we have minus 5 times minus 2. Minus times minus is plus, and then 5 times 2 is 10 minus 7. Right? So let's go down a little bit more, and then we have so 3 times 4 is 12 plus 10 minus 7. So this is 22 minus 7, which is 15, just as we had from before. 15, you can see here. Okay, so instead of doing the whole table and having to redo the other ones, you can just jump on and use this method to just do 1, 2, 3, 4. Okay, so this will make it, because the exam you have to do things like really promptly on time, so you have to choose methods that are more appropriate. Okay, right. Okay, now we are moving on to try and plot this graph. So let's just pause the video. This doesn't seem to want to pause. Right, so this is our graph paper. This is why I encourage you to have a graph paper as you're following on with the lesson. I had to draw these lines because it's really difficult with this tablet to do it. Okay, now what the question asks us to do is to use scales of 2 centimeter. So scales, for us to use scales of 2 centimeter to 1 unit on the x-axis. Okay, and then 2 centimeters to 5 units on the y-axis. Now this is important for you to know. Okay, when you have your graph paper, there are thick lines and very faint lines. Okay, between any of those thick lines, like between this thick line up and this other thick line, this is 2 centimeters. Okay, this is the 2 centimeters that is referred to in the questions. So for every 2 centimeters, you should represent it with 1 unit for the x-axis. And the x-axis is also known as the horizontal axis. Okay, and the y-axis, we can call it the vertical axis. The vertical axis, right? So the values of, and we are given a range. The range we are given for the values of x are for minus, x is between minus 3 and 4, but those numbers are included. That's why you see x is greater than or equal to minus 3 and it is less than or equal to 4. So that's why we included those both. Now, and this is just the table we have been given. So normally this shouldn't be a problem. So when you have your, before you draw these lines, you should know your table. Okay, consider the values you have. For example, if the values of y have more positive, the positive values are higher. Say for example, you have in our own problem, this will be difficult to scroll up because I had to zoom the graph. Well, what we have, the highest value of y, the highest is 35 and the lowest is 21. Okay, no, sorry, the lowest is minus 9. Let me see. Yes, it's minus 9. It's minus 9 is the lowest value of y. So therefore you should know that when you are drawing this graph, if you have a problem of space, the values, the positive values should take more space. So you should try and put maybe this red line around here, right? Because when you look at the negative values, they are not so much. The highest, the most negative number is 9, is minus 9. But in the positive side, you have up to 35. So you want to leave enough space to have that up to 35. Okay, this is key. Often students find that you draw and then there is not enough space. Keep this in mind. Okay, and for the x values, we have minus 3 is the lowest and 4 is the highest. Still, you can see that between from 0, 4 takes more space. In case where you have value, where you have, say maybe for x the highest is, the lowest is minus 2, and then say maybe the highest is say 7. You want to make sure you bring this line, this red line around here, so that you have enough space for the 7 units, for the 7 values you need for the positive side of the axis. Please keep this in mind. Okay, and now when you draw the line, each point is represented by coordinates. So each of these coordinates made up of they are joining the y axis, so which is this axis, and then the x axis. Both of these make up the coordinates and they start at 0. Okay, I think we should use red. So now what you have here, we'll just be looking at the table. I hope you've copied the table down so you can just follow on. Now we'll look at, let me just see how much time we have. 7. When you just be looking at your table, you now take for each, in fact let's label the axis first. Sorry, that's what we should have done. So, and we say 2 centimeter to 1 unit on the x-axis. So from 0, this end is negative. Okay, so we have from here to here, we have, this is the positive side of the axis. So from our table we have minus 3 is the highest. So we start from minus 1, minus 2, minus 3 is what we need. Okay, so here is the point for minus 1, here for minus 2, and here for minus 3. And then for the positive side, we have here 1, we have here 2, sorry, oops. We have here 1, we have 2, we have 3, we have 4. Alright, so each of the thick lines, which is 2 centimeters, is going to be 1 unit. So from this thick line to this other thick line is 1 unit. From this one to this one is also 1 unit. That's what we have for the x-axis. For the y-axis, we have for each of the thick lines, it's 5 units. So we start from 5 for the positive, and for the negative side, we'll start from minus 5. Okay, so here for the positive, we'll continue 10, because for every other thick line is going to be another 5 units. So 5 units plus 5 units is going to be 10 units, and the other one will be 15, and then the other one will be 20, the other one will be 25, and then the other will be 30, and then the other will be 35. See, we have just enough space for the highest value of y, which is 35. And then for the negative axis, we do also the same thing: minus 10, minus 15, minus 20, minus 25. But in fact, we can stop here because the lowest value is just minus 9, so we don't even need to come up to 15. 15 is the top we should have had. Okay, so now let's start plotting our graph. So when in our table we have, when x is minus 3, y is 35, is 35. Okay, so for here you look at the value of minus 3, you trace up where it corresponds with the value of y, which is 35. So we cross that point. This is the point, the coordinate. This is the point representing those coordinates: minus 3, 35. Okay, so we have minus 3, 35. It's 1 point. And then we have the next point is minus 2, 15. Minus 2, 15 is the next coordinate set of coordinates. So minus, let me see, Okay, so minus 2, 15. So here is minus 2 and here is 15. So when x is minus 2, y is 15. We know this is the point of 15 of the y-axis and this is point of minus 2. So where they meet up, imagine both of them walking in the same direction and then they meet up. Okay, so here is the point they will be meeting up. If you move from here coming this way and you move from here coming this way, you'll be meeting up. Okay, so this is the second point. And the third set of coordinates are minus 1 and 1. So when x is minus 1, y is 1. Right? So when x is minus 1, y is 1. Now here is the tricky bit. So when you are dealing with these coordinates, now if we say 2 centimeters is equal to, say, 5 units. Let me just pause and zoom in a little. So we have shape. Okay, we zoomed in to see what's happening here. So as you can see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 small boxes for every 2 centimeters. There are 2 smaller squares. 10 small squares in there. Okay, so what we'll do here, now we've been asked 2 centimeters is what we know is the between the thick lines. Okay, so that is 2 centimeters. So for those 2 centimeters, we have 10 boxes in there. For the graphs you'll be seeing in your examination, this will be the number of squares. So those 10 squares, we'll be dividing them by the number of units, so which is given to us in the question as 5. Right? So we'll know the number of boxes to represent with any number, 1, 2, 3, 4. Okay, so now we know 5 into itself is 1, into 10 is 2 times. So for so we'll be having 2 boxes for 1. So every 2 boxes is 1. Every 2 boxes is 1. So therefore now, if we have here minus 1, when x is minus 1, y is 1. So we know that 1 corresponds to 1, 2. So it's 2 boxes that gives us 1 unit on the y-axis. Okay. So we have where the meet up is here. So what you do, you divide the number of boxes by the number of units to tell you how much each unit should carry as number of boxes. Right? So when we divide 10 boxes by the number of units given in this question as 5, we had ended up having 2. So it means that 2 boxes should represent 1 unit. Right? So that's why we said 1, 2 boxes. Okay. All right. So now we've got the second one. Let's just pause and zoom out again. Well, perhaps we may need this, so let's don't yet. Let's just do these other ones. So when x is 0, y is minus 7. Where x is 0 is this point here, right at the intersection. So when x is 0, y is minus 7. So similarly, we know that this is minus 5. Okay, so we will be counting from here, but we know that on the y-axis every 2 boxes is 1. So now we have minus 5. Minus 5, if we take 2 boxes, 1 box, 2 box. So this is now 6. And then if we take another 2 sets of boxes, we'll have 7. So we have 1, 2 boxes. So now we have 2 sets of 2 boxes. So that's 2 added to the 5, so which is minus 7. So here is the point minus 7. Right? So this is where we cross off. And then we move on to the next set of coordinates. When x is 1, y is minus 9. Right? So we can still remain zoomed. We say when x is 1, y is minus 9. So now we have, if this point here, this is 10, so we know that 9 will be 1 unit less. Okay, and we know that for every 1 unit it's 2 boxes. So we just take this set of 2 boxes here below, 2 boxes less of 10, which should give us 9, because we know we have to move 2 steps to come to 9, right, if we are moving from this end. Okay, so here, so this is the point minus 9 here. Okay, so we come when x is 2, y is minus 5. So this one is exactly lying on the thick line, so we don't have to worry ourselves. Minus 5. Okay, and then for 3 rather, when x is 3, y is 5. So we come 5, the positive 5 is here. So where they meet up, we tick off the intersection as our point. Okay, and then for x, when x is 4, y is 21. When x is 4 here, y is 21. So the values of y are the ones along this end. So y is 20 here. So we want 21. From 20 to 21 is just, we know that every 2 boxes is 1 unit. So we trace the point for x up to 20 first of all, because we know now from 20 we just have to add 1 unit, and for the y-axis 1 unit is 2 boxes. So 1, 2. So we cross it off here. So now we'll pause and zoom out again so we can try and just draw a graph. So okay, now so now this is our we've plot our points, so all we have to do is to join them together to create our graph. So let's perhaps choose say blue color, and then let's try to join. So what you do, you try to make sure it's as smooth as possible, because, and this is important because sometimes they ask you in the questions to estimate values. If you draw it very like crooked or rough, it will be difficult for you to have like your answers will be too far from what you would expect. Okay, so let me try and see how we do this. So we say we try this. So often you try and trace them out first before you, like just hovering on top. You hover on top, like try it out and see how it flows. Let's see now. Right, that's not the best we can do, but that's what we have. So this curve represents, so now we've joined our points to give us the curve. As you can see, the way it came out, because the value is the leading value of the term, so we have y equals 3x squared minus 5x minus 7. Because this value is positive, you see that it came out like a u. If it was negative, it would have come out as an n. Okay, so this represents y equals 3x squared minus 5x minus 7. Right? So this is our plotted graph for quadratic functions. Let's see how much time we have. We have about 2 more minutes. Okay, ignore that. That's for me. Okay, so now we've plotted our graph. Now the next part of the question asks us to use our graph to find the roots of the equation. Okay, so what are the roots of the equation? The roots of the equation are basically where the curve touches the x-axis. Okay, so where it touches the x-axis, if we drew this better, if we had like, it would have probably come out like this. Okay, because I did it earlier on a graph, it came out. So this was our point. So this is the point. If you trace the graph well, I came inside too much. If you trace it well, so this will be the point where it crosses the x-axis. Okay, let's just use this. Let me take that off because it shouldn't matter. What the examiners are looking for is how close or far you are from what they are looking for. So we have this. Okay, here it crosses the x-axis here, and it crosses the x-axis here again. So wherever the curve touches the x-axis is the point you should note for the roots of the equation. Right? So we have the roots of the equation. So we say question C Roman 1, the roots of the equation. So the roots are, so we say the roots are, for the negative axis we have minus, remember for every 2 centimeter here is 1 unit, so it almost crossed it at around 1.9. okay, so minus 1.9. actually when you do it, it comes out as minus 0.9. 0.9. Okay, because it's right here. Okay, it's very close to -1. So on the negative end, it cuts the x-axis at minus 0.9, almost 1. And then so minus 0.9, why was I writing up there? And then for the positive side, it cuts at exactly 2.5. Okay, 2.5. When you draw your question, maybe you'll be around 0.7, 0.8, 1, 1.1. Examiners will accept this, okay, but it has to be within a range. Right, okay, so now that's Roman 1. For Roman 2, we are asked to estimate the minimum value of y. So the minimum value of y is -9, okay, -9, because here the minimum value of y is where like the lowest point of the curve, okay. Sometimes this can be lower than the lowest point you have, but in this case it should have been exactly around that point, right? So -9. So the minimum I'll repeat that, the minimum value of y is equal to -9. Okay, and then finally we've been asked to find the gradient at a point. This is an interesting question that you need to like pay real attention to. Okay, this gradient, so Roman 3 is gradient at x equals 2. So we are asked to find the gradient at a particular point. Now you can use calculus to get this very easily, right? But what you've been asked is to use your graph to get this, okay? And at a point 2, so where x is 2, normally what you do, you try to drop to that where it touches the curve. Where the point they ask if x equals to 2, then you make sure you look at 2 and then drop to where it touches the curve. So it touches it exactly here, okay? And then you draw a tangent. A tangent is just a line that touches the curve at exactly 1 point, right? So now I'll try and use a ruler, but this is difficult for me from my side. Let me just pause the video and draw the line.